Okay, what's up, everybody? We are back with another episode of Hacking Smart Contracts for Fun and Profit. Today, we're going to be looking at challenge number 4, side entrance of Damn Vulnerable Defi. A surprisingly simple lending pool allows anyone to deposit ETH and withdraw it at any point in time. This very simple lending pool has 1,000 ETH in balance already and is offering free flash loans using the deposited ETH to promote their system. You must take all ETH from the lending pool. Okay, let's check out the contracts. So here we got the flash loan. So the top we have an interface, I flash loan ether receiver, and it just has a function execute. Scrolling down a little bit, we see we have a mapping here of addresses to uints, and it's called balances. This is some accounting stuff, so we can keep track of balances in different addresses. And then we have a function called deposit, and then we can see here it takes this mapping, the balances, it inputs the message.sender, and then it increments the address by whatever value is sent or attached to the transaction. Next, we have the function withdraw. Here, amount to withdraw is the balances. So here it checks the mapping of the message.sender. This is the address, and it will check for whatever value is associated with this address. And then next, let's see, balances message.sender equal to 0. And then payable, it will send. So this is the amount to withdraw. So it creates the amount to withdraw, is whatever value is in there. And then after that, the balances is going to equal 0 because you withdraw everything. And then we send it to the message.sender, whatever the value of the amount associated with that address is here. Next, we have the flash loan function, balance before. We're just checking the balance of the pool at this point, and we're making sure, once again, we have enough tokens to lend out. And then after we do the check, we execute, or we trigger this execute function in the interface. This is from the interface up here. We trigger this with a value amount here. So whatever is associated, whatever value is associated with the function call, it will execute. And then we check to see if the flash loan is paid back at the end of the day. Okay, cool. So what's going on here? I guess the overall take here is going to be with external function calls, basically. Can you trust other contracts that you're calling to? And you have to make sure that the calls you're doing to other contracts are doing what you want it to do. Because sometimes because your contract is safe, it doesn't mean other contracts are safe. So you have to make sure that you're really cross-checking the logic. When you start calling different contracts, you can run into some trouble because they can end up doing things that you don't really want them to do or expect them to do, really. So that's part of the gift and the curse with composability and smart contracts, because we can start connecting all these different contracts together and doing function calls on different contracts, which is awesome. At the same time, we have to understand what is exactly happening on these different function calls, because we can run into some trouble if we don't quite understand the total chain of actions that's happening here, which we will see in a minute here. So basically, we're going to kind of do a a side entrance attack on this. We're gonna, yeah, we're gonna kind of hijack this execute function here and make it do stuff it's not really supposed to do. Let's get into it, and I think you'll understand it better once I start coding it up. Okay. Let's copy a bit of the first of this just to get us going. Okay. Let's see here. Import Zapun. Okay. So we need an interface again to this lending pool. We just call it, usually once again you start with I for interface. We call it I side pool. Sure. And then let's go grab the functions we want to interface with. So we'll want this deposit function. External payable, yeah, that all looks good. So we want deposit. We want the withdrawal. And we want the flash loan. Okay, and I think that's good. Contract, we called it side attack. Here we're using address for address payable. And we will create just a variable for the pool, call it pool. And we will just initialize the pool. Side pool. Score. Initialize the pool. We'll say pool equal to pool. Cool. So we initialized our pool interface, and then we can just code up our attack function. We'll call this attack. We're not gonna pass it any sort of input. We will make it external. So first thing, we want to get the pool balance. Get the pool balance. Uint 256. Call it pool bal is equal to. So here we can do it a little differently because we don't have a token, which in the previous challenges we had a token. We do the balance of. Here we can just say address of pool, and then we just say balance. This will give us the pool balance. And we can do this. This is how you kind of do it when you're referencing Ether. So once we have the pool balance, we can take a flash loan. We say pool dot flash loan, and the amount we want to take the whole. We want to take the whole thing. We want to take the whole cake. So we'll say pool dot flash loan dot pool balance. So what's going to happen here? I guess just before I forget, when we're dealing with Ether, we need to put in. Let's see, receive. Oops. We need to put in this receive. I don't know if you call it a receive function, or you just need to put in this. You need to add this line of code so that we can receive. We can receive Ether into the smart contract. External, and we need to make it payable. So like that. So now we can receive Ether into this contract. So back to here. Once we take the flash loan, we are going to trigger, it's going to be looking for this execute function. We could create a fallback function if we wanted to, and then when it doesn't find, let's see, where is it? So there's execute. Once we trigger the flash loan, it's going to be looking for this execute. And if it doesn't find it, it will just trigger the fallback function. But we can just also just add this execute function, and then it will just find it in our contract and then execute the logic we put in there. So let's just do that. Yeah, we'll create a function called execute, and then we need it to be the same as this. So it's going to say up here, it's going to say execute, but it's gonna want a value here. So we need to attach a value, and also we need to make it payable, external and payable. Execute. Oops. Execute here. Uint. We can just say amount. External, and we also need to make it payable. Okay, so basically here what we want to do is when we trigger this execute function, we're actually gonna, so we have the flash loan at this point. When we have the flash loan, we come into this execute function, we can then deposit this flash loan into the here, we can trigger this deposit function, which will increment our balance, and it will make us think that the balance on our account is the total amount of the flash loan. And then from there, we're just going to withdraw it because the account thinks that, okay, cool, he deposited X amount of dollars. He wants to withdraw, give him his money. So that's what we're going to do. So we're going to go function, execute uint here, and then now we're just going to call pool.deposit. But we're going to, see, we have to attach the value of how much, we got to tell it how much we want to deposit. And we do it like this. We say value, and then we just say message.value. And it's going to deposit the value of this message. Actually, I guess we don't need this then. It's just, can I just do it like that? Execute. Better hurry up. I think I can just do it like that. Maybe I don't even need this. I think I can just do it like that. Okay, so once we deposit, we're going to increment our balance of the pool, and then we're going to have the complete pool balance of this flash loan pool. So then we can go back into here. We can just withdraw the flash loan by saying pool.withdraw. Then after that, we're going to have the flash loan completely drained into our attack contract right here. So we can just, from here, we can just transfer flash loan into the attacker EOA. So we can just say here, we can do like a payable message.sender. We can say transfer. We can say transfer So this is kind of how you transfer out Ether. We're going to say address this balance. This is going to transfer the total balance of whatever ETH we have in here into the message sender, whoever calls it. So I think that's good for our attack contract. Let's go over here and code up our test. So once again, this is just pretty much basic test setup. Let's go, we can go this.hack equals await ethers dot get contract factory. We call it side attack. We can call it from the attacker, deploy, and then we have to look. We just did the pool, so we just say this.pool, just to get a reference to the pool. And then that should be initializing and deploying the contract, our attack contract. And then we just say this hack dot attack. And then that should do it. Let's try it out. Yarn run. We want to run side entrance. Let's see. Come on, come on. Waiting. Oh, boom! We hacked it. And we've completed the side entrance challenge. So thanks for joining us, and check us out next time.